Hello guys, my name is Harjeet. I am a student of Ravensbourne University. Today I wanted to share my eco-print project with you. The eco-print project represents a forward-thinking response to the environmental, social and economic challenges linked to the widespread use of petroleum-based 3D printing filaments. This presentation explains the project's original, its project's process map, the sustainability incremental strategy adopted, and the advantage of using a digital project management tool to structure and visualize the work. EcoPrint is designed as a biodegradable filament produced from agriculture waste such as corn huskers, fibers, and rice straws, allowing the project to support both low carbon production and rural income enhancement. The core motivation behind ecosystem lies in the recognition the conventional 3D project printing filaments contribution to pollution, greenhouse gas emissions, and low-term waste occupations due to their petroleum dependency. By transforming agriculture residues into functional filaments, MS project plays an essential role in this transformation because it helps capture the workflow and map out sustainability touchpoints across the entire life cycle of the project. The project objectives provide a clear structure for decision making. EcoPrint aims to reduce plastic waste, minimize fossil fuel dependency, and demonstrate the sustainable biopolymers can perform effectively in makerspaces, educational environments, and creative studios. Beyond environmental benefits, the project supports local communities by creative opportunities for farmers to earn additional income through the supply of agriculture waste. It further encourages the development of green skills in education and creative sectors. Financial resilience is also part of our objective in ensuring that EcoPrint can generate diversified revenue streams, attract partnership, and maintain sustainable operators. This combination of environmental, social, and financial objectives ensure that EcoPrint aligns with the broader sustainability frameworks and meets the long-term industry and community expectations. The the process map developed in MS project illustrates in detail how agriculture waste is transformed into a high quality biodegradable filament. It begins with the collection of feedstock from farmers and partners, followed by cleaning, drying, and grinding to prepare the fibers from refinement. Contaminants must be removed to ensure processing efficiency and the final product quality. Once refined, fiber undergo blending with the natural blenders and plasters, and the mixture is extruded into a filament. The filament is then cooled and tested and funded out. The considerable spools MS project is crucial in organizing these steps because it allows the project team to identify which tasks must be completed and which can run in parallel. While by defining defenses, assigning resources, and visualizing critical paths, the digital tools ensure that the workflow remains efficient and efficient. The process map also highlights where sustainability principles are integrated, such as waste reductions and in the cleaning stage, energy management during extractions, and circulation packaging designs. During the initial phase, the project frames its sustainability intentions clearly and identifies the key stakeholders involved. This includes farmers supplying agriculture residues, designers and engineers involved in product development, sustainability monitoring, environmental performance, educational installations using the filaments from learning for learning, distributors is responsible for marketing, delivery, and regulatory bodies overseeing compliance. Stakeholders mapping help categorize these groups based on their levels of power and interest, which then informs engagement strategy. For example, farmers have high interest but limit influence over project direction, which means that they it requires a sportive engagement and equitable compensation. Meanwhile, the designers uh, and users play a significant role in shaping project product expectations and adoption patterns. Ethical considerations form an important part of this phase, ensuring sourcing practice remain fair and community participation encouraging from the beginning. The planning phase use MS Project to translate strategic intentions into actionable tasks and timelines. Can chart outline the life cycle of a project, dividing into initial planning, monitoring, and closure. Each phase includes a specific milestone such as material sourcing, reliance, quality assessment, compliance, testing, and packaging approval. And the planning process also addresses potential risks including variability in feedstocks supply, potential delays in productions, changes in environmental regulations and fluctuations in the market demand. Mitigation strategy and built into the schedule such as flexible manufacturing timelines, diversified suppliers, networks, and regular policy monitoring. Execution is the phase in which the operational element come into the practice. Agriculture waste is collected and processed based on the workflow defined into the process map. Each step from grinding and fiber refinement to the blinding and extraction flows strict quality assurance protocols to maintain product consistency. Supplier evaluation frameworks ensure that the sourcing of agriculture waste aligns with the environmental and ethical standards. MS project assistance by tracking task compliances, monitoring executions, energy use, and identifying mm, in inefficiencies that may require adjustments. Packaging decisions also reflect sustainability ambitions by using compostable material and reinforce equipment equipments complementers and to low impact production. Monitoring and control continued throughout the project execution. Key performance indicators include the feedstock quality, processing time, material loss rates, supplier reliability, and compliance with the sustainability standards. MS project dashboard tools help visually the data in a real time, enabling the project team to respond quickly to deviations from the plan. Resource utilization chart support decisions on labor allocation, energy demand on machinery efficiency. Risk monitoring remains active especially in relation to the to supply chains, volatility, production delays to market uncertainties, and continuous communication with supplier stakeholders ensures smooth coordination and reinforces transparency throughout the process. Digital procurements tracking further enhance governments by ensuring that sourcing practice remaining aligned and with sustainability complements. Sustainability integration is central to eco-print identity. Environmental sustainability is achieved by reducing landfill agriculture waste and replacing petroleum-based plastic with biodegradable, low-impact material. Social sustainability is promoted by supporting fair competition from farmers, involving community partner in pilot testing and ensuring equitable access to sustainable material and education and creative users. Economic sustainability is reinforced through diversified funding sources and long-term models that sustainabilize operations. Trade-offs such as potential land use conflicts and addressed by strictly using agricultural residues rather than primary crops, which ensures that eco-print doesn't interfere with the food production and contribute to land pressure. MS Project enhances sustainability management by offering features such as milestone tracking, real-time dashboards, scenario modeling, and predictive scheduling. These capabilities strengthen decision making and make it easier to visual environmental and operational indicators at every stage of the project. They also support accountability, particularly when coordinating complex supplier networks and monitoring uh, resource in intensive steps like exploration. In conclusion, EcoPrint demonstrates how agriculture waste can be transformed into a promising sustainable material for modern manufacturing. The project integrates environmental, social, and financial sustainability principles throughout its life cycle and uses a digital management tool to coordinate the process effectively. Lessons learned from the project highlights the importance of transparent procurement, diversified sourcing, risk responsive planning, and continuous performance monitoring. Ecoprint utility, Ecoprint utility positioned itself as a creative, sustainable innovation capable of advancing circular economic practice in the creative education and manufacturing sector. That are references which are related to my project. Thanks for watching my presentation.